The older the house, the more likely you're gonna see weirdly built crawl space, which will be definitely not up to today's building codes. Especially it applies to houses in suburban and rural areas or very small towns that back in the day didn't have any regulations coming out of their municipalities. It feels like everyone was building however they wanted. As much as you can try to save the situation and work with crawl space underneath leveling floors and putting supporting piers that I described in one of my videos, sometimes the best and arguably easier way is just to say screw it and rebuild entire crawl space, if you know how to do it. I purchased 2 properties in small town, almost rural area with a population little over 2,000 people, and one of the houses had messed up unleveled flooring that I recognized, but still decided to let tenants in for decreased rent and to work on the issue after they move out. My duty to remodel the property came way before tenants' lease expiration, as they completely killed off the property, even making dog kennel out of one of the closets, tearing up floors down to subfloor. I had to evict them. I wanted to do full remodeling and I knew floors need special attention, but when we started inspecting them closer, we found out that they are not just unleveled, but also have different height in some rooms compared to others, due to double layers of plywood that has been laid to mask overall issues. Also, entire crawl space framing was incorrect, so the plan with reinforcing subfloor and putting extra piers would hardly work and definitely would be nothing but headache, with how soft was plywood and how unleveled it was. All the plywood was stinky in the room where the dog lived. We started demolition planning to replace entire subfloor as a plywood and work on putting extra beams to support new one. You can see on the video how in some spots there was double layer of plywood and somewhere even triple. Further down during demolition, we recognized even more how messed up was the entire framing of crawl space, with no hangers for joists, not enough supporting beams, random way how wood was attached to each other, how deteriorated was the wood, so we decided to go the best possible route to get the project done up to high standards and rebuild entire crawl space. And you can see all this craziness on the video. I'm not surprised this house is in a small town in a rural area. There is no way something like this could be pulled through in bigger municipalities even long time ago. This property was relatively small, just 750 square feet. So our first step was to split house in sections, in our case it was split in half, and work one at a time, running brand new girders, beams and joists on the top, and at the same time support the walls from falling down, as we didn't want to do additional framing on rebuilding walls. But you might consider doing it, as it's a little easier, will be more costly though. Important. Remember that you must be extremely careful with what you're doing, and the best and correct way to do proper work is to hire a structural engineer who will inspect the property and point you in the right direction what should be done. If you don't have extra few K to spend on engineer and you already decided to do work yourself, first thing what you need to check in the framing is where is load-bearing wall in your property. You will see further in the video how we were doing our work, but simply speaking, load-bearing wall is one of the main structural elements of your building that holds the weight of the elements above, including roof framing itself, by conducting its weight to a foundation structure below. So you really need to determine where is load-bearing wall in your property and plan how you can work around, as you're gonna need to put additional very stable supports underneath it if you plan to remove and rebuild framing below. After full demolition of first section of the house, we temporarily left few joists supporting the wall there. If it's not load-bearing wall, most likely it's just framed on the top of subfloor by 2x4s and drywall, so it's not holding any weight and you can almost leave it hanging, unless it's a huge size wall, and in this case just the weight of wood in it might be quite remarkable to consider, because the gravity is pulling the wall framing down, which is tied to the ceiling and framing above. So typically still try to put some support underneath. You can keep existing joist like we did and replace it later. We went through stages from having joist and supporting board with pillar underneath just to having joist with shimmed pillar. After first section has been cleared, we can work our way and start reframing. Depending on the size of your house and square footage, the span between beam supports vary. You can refer to building codes for precise numbers, but I would say if it's continuous board, you should be fine with no more than 16 inches spacing apart. Based on our square footage, we were going with 3 supporting beams throughout the area with around 14 inches span between them. We ran the string line where we plan to have first beam so we can start digging dirt to pour concrete slabs there as the footings. Preferable size of your footing is 2 by 2 feet with depth at least 1 foot. Might vary depending on local building code. And the span between the piers underneath the beams, and accordingly footings themselves as 8 to 10 feet apart should be sufficient. So your construction from the ground up and scope of work will look like this. Footings in the dirt. Piers out of cinder blocks, supporting beams, floor joists, plywood subfloor. All floor is gone. So we removed the floor, the subfloor, the joist, the beams, and pretty much you can see the walls just supported by a couple of pillars. Here's the one pillar for that wall, another one like a small dividing wall supported by the old joist. The middle of the house is supported by how many pillars? Let me see, because we got out of the joist. 1, 2, and 3. The house wall's framing sits on the cinder blocks with 2 by 8 boards running around the perimeter. Previous subfloor was on the top of it with all joists connected. All of these boards around the perimeter were in great shape, so we just plan to double them with brand new 2 by 8s that will serve as our main external part of framing. It's critically important to install these boards correctly leveled, as they pretty much form the outer shape of your framing inside of which you will be running your joists. You can play around figuring the best corner of the house to have starting point. We just chose the corner in the first section where we done all demolition. We set self-leveling laser on the board we put across in the corner. Then we had to mark all of the outer walls so we have reference lines where to run our new boards at. We didn't want to play much with going through steps to mark the corners and walls on the opposite side of the property when it's covered by existing walls, so we just cracked dry walls in several spots to open up few holes for straight laser access. After we set the laser on a few boards in our first corner as the starting point, as you can see we had 6.5 inches difference from the top of outer framing board to laser line. But on the other side of the house, it's 5 inches. So either it was improperly built or one side of the house sank an 1.5 inches. Most likely it's a poor build since cinder block's foundation looked steady and in great shape to us. But we need to factor difference in height for our future framing so we can have everything leveled. Next step is starting framing the first section. According to the level we planned, we started shooting brand new 2 by 8 boards along the perimeter to existing ones. We used heavy-duty framing nail gun Hitachi and good quality air compressor from DeWalt. Double check with regular level to make sure you laying everything accurately. Also important to install your framing depending on the door location so you don't need to move the door. Let's say you have a door at certain height. You put 2 by 8 boards slightly below, accounting for 3/4 inch of the plywood you will be putting on the top and what would be the thickness of flooring. Ideally you want to have everything flush or close with the level of the door. Because you're doubling the board, it will be slightly away from the wall depending on how deep original one is sitting. But it's not a problem since you're still gonna have shoe molding or baseboard on the top of plywood, and it's just not enough load you theoretically can create if you step on the very edge there in order for plywood to bend down. Then we ran the joist as 2 by 8 boards all throughout first section parallel to each other. The span between your joists should preferably be 16 inches. All of the joists should be in precise distance from each other because remember, you will be laying plywood on the top and the sheets should meet each other perfectly in the middle of joists. And obviously you run them across the supporting beam you will be putting underneath and all of the footings for it. You nail your joist to outer boards the same way with framing nail gun. Install joist hangers underneath the joist, simply nailing them to the outer boards. Very important part of your construction is supporting beam underneath the joists. You can pretty much use any significant size of the board. Since we had in pile all 2x8s for framing, we just doubled 2. In our project, we were going literally from the top to the bottom, when typically in brand new constructions it's opposite. It's not shown in the video for this section, but we pretty much nailed with the height of our cinder block piers to set the supporting beam on. But you obviously can try to measure and plan starting from footings and height of cinder blocks sitting one on one. Before setting the beam, you can have the ends of joist rest on the board you put across. But very important step that should not be underestimated is checking with level all of the joists to make sure they are flat leveled before putting permanent supporting beam underneath. And you might need to shim the beam if that's necessary step to get the joist leveled. Under the wall we had all joists that we slightly lifted up with hydraulic barrel jack, and this is very important and useful tool you must have in your arsenal for this job. Of course, if you want to keep the walls, or mess with load-bearing wall, because you're gonna need to jack them up slightly to run other joists or plywood underneath. We didn't cut existing old joist underneath the wall, but ran additional continuous long 2x8 right under. Looking ahead, I'm gonna say that eventually we decided to remove this wall to have open concept living room and kitchen. We put first sheets of plywood on our newly framed section so we could have some steady space where to walk on, because being for so long in the dirt, jumping over all the new joists was getting annoying. Whatever was underneath the wall, we just met with new plywood on the sides. Obviously make sure you have edge of joist by the wall so you can lay the plywood sheet on it. And we got another supporting beam on the end of the joist, which is again double 2x8s. On this footage you can see all the craziness under the main wall in the middle of the property, what we assumed to be load-bearing wall, that was pretty much sitting just on random piers. We decided to work with it in the end, and our team moved to second half of the house to clear out and work with that section. It had couple of walls framing bathroom, and all of them we wanted to keep. So the plan was to lift up and put supports underneath the walls to hold them, and after we can cut all of the remaining deteriorated old wood and run new framing. With hydraulic jack we started lifting up the walls. And it was the wall right in the same line with the one we kept in another section where the lack of engineer expertise showed up. I would like to say on accident, but it's just what happened. By slightly lifting up that wall, we raised entire part of the house. What that means is that the framing on the top were the roof rafters, attic and its connection to the walls, and what we assumed to be load-bearing wall was different than what we anticipated. By looking at the house from outside, you can recognize specific shape how the roof was built, because it didn't have typical 2 sides but had 4, and they weren't the same size built symmetrically, but had specific shape. Again, without good construction experience of feeling the house and framing, you might better refer to inviting an engineer first, who will determine load-bearing walls for you and which framing in the property is structural and not just built on top for drywall installation. Since this wall we went on was quite small, we actually decided to go bold, take down all of the attached wood and let it hang, instead of doing opposite and push it up for the sake of support, because potentially it could damage the framing on the top, since like you saw on the video, jacking this wall up was lifting entire house. Also, we removed all the rotten wood in the framing of this wall itself, so we can replace it with new one. And if you're doing remodeling of older houses, you always need to be prepared that in the bathrooms and often in kitchens, not just drywall, but all of the wood behind will be rotten, moldy and deteriorating. We still had barrel jack and temporary pier under the wood framing below the bathroom, but one by one cracking wood down, we just removed everything and left all of the bathroom walls hanging. Some of the old plumbing that was on the very bottom by the ground, like sewer lines, stayed in place, but if it's leaking, obviously it's better to get rid of it and put new one before running new framing. After all of the old wood was removed, we dug the holes for footings to put the piers on for new supporting beam underneath the future joists. I'm staying across or along the main beam in the middle of the house with the joist laid on the top. On the left side, the side that we were working on, the subfloor already in place. We got one more supporting beam in the middle. And on the right side, that's where we're working on right now. So everything is already cut out, and there is the footings, the concrete poured for the future pillars, the piers to support the new beam, and the joist not meeting existing ones, but going right on the left and on the right side, whatever side we're gonna choose, and go across a couple of feet down. We started running joists from the other side of the house, the same interval 16 inches apart of each other. Because my guys incorrectly installed the outer board of framing, not leveling it properly, they had to connect the joist about 1 inch lower than the top of the board. The other corner of the same section we were working on had the same issue, which is fixable. The top of the board was cut with the saw to be flush with level joist to allow plywood sheets to lay above evenly. One of the biggest challenges we had is to slide all of the joists underneath the main wall that we assumed first to be load-bearing wall, which wasn't 100% but definitely had some good burden of attic framing on it. We slightly jacked up entire wall on both sides, and the pillars it was staying on were shimmed, so we had room underneath for joist and plywood. On the video it looks messy what is below, but the bottom line, we worked gradually putting joist by joist and made sure there is still some support underneath this continuous big wall. You can see the supporting joist beam was already installed underneath and put on piers, so we just had to continue laying joists on it sliding underneath the wall. As you can see, the joist met in the middle going opposite ways but sitting on the beam in the center. Remember, you need to account for where the joists gonna meet if they run farther than the distance between the wall and beam in the center, so you have them preferably right next to each other. Some of the wood underneath the main wall had to be cut out as well, so we can slide brand new plywood sheets there. But again, be careful. Try to support it anyhow you can unless you're positive it doesn't bear any load at all. This footage is demonstrating how the joist was put underneath one of the bathroom walls and main wall, and space in between. Obviously use barrel jack in the areas where you can't freely slide plywood. All of the walls typically framed sitting on 2x4s. Make sure the wall is sitting on plywood tightly, so when you knock it under the wall, you might see it's moving. Then adjust it, making straight. Because of all your manipulation with walls, obviously some of them will be floating, sagging, and the door trim will be all shifted and far from being perpendicular. A lot of our walls were left hanging up in the air. I guess you understand we were fixing it, adding 2x4s wood underneath, and then, when wall is stable on this so-called board platform, you can adjust or put new trim on the door perpendicular how it should be. Also, your ceiling level will not be perfect either, but you can play with the trim, making it almost unnoticeable unless checked. Remember, perfect framing is built in new constructions. In our case, we're just fixing messed up old houses, trying to do the best. At the same time, we were targeting the most visible part as flooring to be leveled, and we achieved our goal. Here is the final look of our brand new subfloor with new framing underneath. My opinion, we absolutely killed it. We ended up removing that wall across we had in our first half of the house we were working on to have open concept living room with the kitchen. But as I mentioned in the video, because of weird framing of the roof and attic, we decided to be safe and put nice supporting posts under the ceiling framing that looked very appealing and was getting complimented by visitors. And here is the final look of remodeled property. Hard work paid off. I hope this video was helpful to you. Please like it and subscribe to my channel not to miss on future home improvement and construction projects.